Express the number in scientific notation. Well, let's take a look and see the format of scientific notation. Scientific notation would be a number where we have one digit before the decimal points, and we have as many numbers we want after the decimal points, times 10 to the power of some number. So that would be a format of the scientific notation. In this case, the decimal point that we have is right in front of the last zero. We need to move this decimal point where we get the format of scientific notation right in front of 3. To do that, we have to move this decimal points to the left 1, 2, 3, 4, 5, 6, 7, 8 times. So we would get 3 decimal points, and then we have 4 times 10 to the power of, again we're moving this 1, 2, 3, 4, 5, 6, 7, 8. So that must be plus 8 or minus 8. So just by looking at the number, this number is obviously larger than 1. If the number is larger than 1 we begin with, so the exponents must be plus 8. If the exponent is minus 8, then it would be the number less than 1. So we have it in the form of scientific notation, 3.4 times 10 to the power of 8. Express the number in scientific notation. The format of scientific notation is where we have a number the digit before the decimal point is only one digit, and we can have as many numbers after the decimal points, times 10 to the power of some number. In this case, our decimal point and 1, 2, 3, 4, 5, 6 zeros here. Decimal points is right before the 6 zeros, followed by 5 to 1. To change this to the scientific notation, we must move the decimal points right in front of number 5. So we have 1, 2, 3, 4, 5, 6, 7 times the decimal points needs to be moved, so we have the format of the scientific notation. So we have one digit here, 5, and then decimal points, and then 21 goes right here, times 10 to the power of, again we count how many times we move the decimal point. So 1, 2, 3, 4, 5, 6, 7. So here would be either plus 7 or minus 7. And again, by looking at the number, we can see this number is less than 1, so this must be minus 7. If this number was larger than 1, then we would put plus for the exponent. So here we have it. The scientific notation is 5.21 times 10 to the power of minus 7. Simplify and write the results in scientific notation and standard form. Here we have 2/4 times 10 to the power of 2 over 10 to the power of minus 5. 2 over 4 is 1 over 2 when we reduce them. Here recall a to the power of n over a to the power of m. It's equal to a to the power of n minus m. So we have to subtract exponents. It would be 2 minus 5. So we have 1/2 or 0.5 times 10 to the power of, here we have 2 minus 5, which is 2 plus 5, which would be 7. Now, is this a scientific notation? The scientific notation should look like a digit and a decimal point, and after that we can have as many digits as we want, times 10 to the power of some number here, either plus or minus. Obviously, this is not in that form because the decimal points must be right front of 5 to have this format. So to make 0.5 as a scientific notation, we have to move the decimal points one digit to the right. So we have 5.0 times 10 to the power of, well, we moved the decimal points only one time, so it would be either plus 1 or minus 1. As you see, 0.5 is a number which is less than 1, so this must be minus 1. So if the original number is less than 1 already, the exponents must be minus. And then we have 10 to the power of 7 here. So we can combine these two. So we get 5.0 times 10 to the power of, here we're adding the exponents. So you have a to the power of n times a to the power of m. We have a to the power of n plus m. So that would be positive 6. Minus 1 plus 7 would be positive. So this would be the scientific notation form. And in standard form, this is simply is 5 followed by 6 zeros. That would be the standard notation for part B. Give the name and state the degree of the polynomial. The degree of a term is the sum of exponents. On the variables. So for part A, degree is 5, and also we need to know the name of the polynomial. We have to count how many terms do we have. We have 2 terms here, and this is known as binomial, means two terms polynomial. For part B, degree is 2 because the first term has a degree of 2, the second one has a degree of 1, and then you pick the highest one, so the degree of the whole polynomial would be 2. And here we have 3 terms, 1, 2, 3. So the name of the polynomial is trinomial. Tri means having 3 terms. So, for example, if we have a term with multiple variable, like 2x to the power of 2y, this polynomial has degree of 2 plus 1, which is equal to 3. Because the exponents for x is 2, the exponents for y is 1, we add the exponents, so the degree of this term would be 2 plus 1, which is 3. Whereas with our examples, part A and B, we have a single variable, so we didn't have to add the exponents. The degree for the first term in part A is 5. That's the highest degree, so the degree of this polynomial is 5. And for the second one, the degree of the polynomial is 2. Evaluate 1/2 to the power of minus 3. This would be the same as 1 to the power of minus 3 over 2 to the power of minus 3. Recall, if you have a term with a negative exponent, we can change the negative exponents to positive exponents by using this property. A to the power of negative n is equal to 1 over a to the power of positive n. So in this case, also true that if you have 1 over b to the power of minus n, you can make this positive by placing the b at the top of the fraction. So to make both exponents positive, we move 1 to the bottom of the fraction and 2 to the top of the fraction, so we would get 2 over 1 to the power of 3. So you notice that when we have a fraction like a over b to the power of minus n, we can write this as a to the power of minus n over b to the power of minus n. And as you see, we have b goes to the top of the fraction to becomes positive for the exponent, and a goes to the bottom of the fraction. And as a result, we would get b over a to the power of n. So you look at this carefully, a over b to the power of minus n is the same as b over a to the power of n. Looks like it's reciprocal. So in our example, 1 over 2 to the power of negative 3 becomes 2 over 1, which is a reciprocal of 1/2 to the power of 3. So this means simply 8. 2 to the power of 3 could be 8. And 1 to the power of 3 is 1, so the answer here is 8. Evaluate 1 over 3 to the power of minus 4. Recall a to the power of minus n is equal to 1 over a to the power of plus n. Or if you have 1 over b to the power of minus n, the same as b to the power of plus n over 1. So in this case, to make this positive, we can write this as 3 to the power of plus 4 over 1. 3 to the power of 4, multiplying 3 by itself 4 times, 3 times 3 times 3 times 3, which is 9 times 9, 81. Evaluate 4 to the power of minus 3. Okay, recall a to the power of minus n is the same as 1 over a to the power of plus n. So here our base is 4, our exponent is negative 3. We can make the negative 3 to be positive 3 by writing this as 1 over 4 to the power of 3. So it would be 1 over 4 times 4 times 4, which is 64. Evaluate minus 4 minus times 4 plus x to the power of 0. So this is like a minus 1 times, in the parentheses, 4 plus x to the power of 0. Recall a to the power of 0 is equal to 1 as long as the exponent is 0, regardless of what we have for the base, the result would be equal to 1. So 4 plus x to the power of 0 would be equal to 1. Negative times 1 would be equal to minus 1. Evaluate 7 to the power of 0 plus 4 to the power of minus 1 minus 2 to the power of minus 2 times 3. Recall a to the power of 0 is equal to 1. A to the power of minus n is equal to 1 over a to the power of plus n. So 7 to the power of 0 would be equal to 1. 4 to the power of minus 1 would be equal to 1 over 4 to the power of 1, or 1/4. 2 to the power of minus 2 would be 1 over 2 to the power of 2, positive 2, times 3. So we have 1 plus 1/4 minus 1/4 times 3. We have to follow the order of operation here. From left to right, we look for parentheses and exponents, which we don't have anymore here. We look for multiplication and division, which is the first multiplication is here. So this would be minus 1/4 times 3, which is equal to 3/4. So we have 1 plus 1/4 minus 3/4. So if I make all these like a fraction, the LCD in this case is 4. So I have to multiply the first fraction with 4 over 4. So I would have 4 over 4 plus 1 over 4 minus 3 over 4. I would get 4 plus 1 minus 3 over 4. 4 plus 1 equal to 5. 5 minus 3 would be equal to 2. 2/4. And I reduce this to 1/2. Simplify and write the answer with only positive exponents. Minus 5 a to the power of 2 b cubed c times 4 a to the power of 2 b c to the power of 2. You recall a to the power of n to the power of m is equal to a to the power of n times m. So in this case, we have the exponents 1 for 4, 1 for b, and 1 for c, where I have to multiply the exponents 2 with these exponents. So I would have minus 5 a to the power of 2, b to the power of 3, c, and over here I would have 4 to the power of 1 times 2 is 2, a to the power of 2, 2 times 2 is 4, b to the power of 1 times 2 is 2, and c to the power of 1 times 2 is 2. Recall a to the power of n times a to the power of m is equal to a to the power of n plus m. So in this case, I have a to the power of 2, a to the power of 4 with the same base. So if I combine those two, I would get a to the power of 2 plus 4. And I have 2 with the same base, which is b. That would be b to the power of 3 plus 2. And when I combine the c's, this would be c to the power of 1. So I would have c to the power of 1 plus 2. And then I have these two numbers to multiply with each other. So I can go ahead and multiply negative 5 times 4 squared for 4 to the power of 2. Which is negative 5 times 4 times 4, which is 16. So I have 16 times negative 5, which is equal to negative 80. So I can start with that, negative 80. And then I have a to the power of 4 plus 2, which is 6. B to the power of 3 plus 2, which is 5. And c to the power of 2 plus 1, which is equal to 3. You notice that we don't have any negative exponents here. If we had any negative exponents, then we had to change those to positive by using a to the power of minus n is equal to 1 over a to the power of plus n, which in this case we don't have to do that. Simplify and write the answer with only positive exponents. 10x to the power of 3, y to the power of 2, z to the power of 5 over 25 x to the power of 3, y, z to the power of 7. You can write this as 10 over 25 x to the power of 3 over x to the power of 3 can be reduced. Y to the power of 2 over y to the power of 1. And z to the power of 5 over z to the power of 7 can also be reduced individually. Recall a to the power of n over a to the power of m is equal to a to the power of n minus m to the power of 1 over 1. So as you see, the result goes to the top of the fraction. So 10 over 25, both are a factor of 5, obviously. So we can write this as divide 5 into 10, that would become 2. Divide 5 into 25, that gives you 5. So we have 2 over 5 times x to the power of 3 minus 3, y to the power of 2 minus 1. Remember, the exponent here is 1. And z to the power of 5 minus 7. So we have 2 over 5. This would be x to the power of 0. Y to the power of 2 minus 1 would be 1. Z to the power of 5 minus 7, which would be minus 2. Well, a to the power of 0, anything to the power of 0 is equal to 1, and we could expect that here because remember x to the power of 3 over x to the power of 3 is equal to 1. We could reduce that as 1 before. So we have 2 over 5 times y, or y over 1. Now here we have to make the exponents positive. If you have a to the power of minus n, you can change that to the positive exponents by using this property. So this would be 1 over z to the power of 2. So if we put them together, we get 2y at the top of the fraction, 5z to the power of 2 at the bottom of the fraction. simplify and write the answer with the positive exponents. Top of the fraction we have 4 a to the power of minus 2 b to the power of minus 5 c to the power of 5. At the bottom of the fraction we have 6 a b to the power of 5 c to the power of minus 2, and the whole thing is to the power of minus 3. So we can reduce some of these first inside the parentheses. I see that we have 4 and 6, both are factor of 2. So if I divide 4 into 2, I would get 2, and divide 2 into 6, I would get 3. So I'm dividing 2 into 4 at the top of the fraction, and also I divide 2 into 6. That would result into 2/3. So here I have my property a to the power of n over a to the power of m is equal to a to the power of n minus m. So let's go ahead and do that. Here inside the parentheses I have 2/3, and here I would get a to the power of negative 2 minus 1. Notice that the exponent here is 1 over 1. And then I would have b to the power of minus 5 over 1 times c to the power of 5 minus 2 over 1. And the whole thing would raise into the power of negative 3 later. So here we have 2/3 a to the power of negative 2, negative 1 would be negative 3. b to the power of negative 5 minus 5 would be negative 10. And here is 5 plus 2, which is 7. This whole thing is over 1. The whole thing should raise to the power of negative 3. So if I do that now, as you remember, a to the power of n to the power of m is equal to a to the power of n times m. And the exponents for 2 and 1 both are 1 here. So I would get 2 to the power of 1 to the power of negative 3 would be 2 to the power of negative 3. 3 to the power of negative 3. And here I get a to the power of negative 3 times negative 3 would be positive 9. And then we have b to the power of negative 10 times negative 3 would be positive 30. And c to the power of 7 times negative 3, negative 21. You just have to move all the exponents so I would have a positive exponent for all of that. Again, recall a to the power of minus n over 1 would be equal to 1 over a to the power of plus n. So here I would get 2 to the power of positive 3 at the bottom of the fraction, 3 to the power of positive 3 at the top of the fraction. But then I have to change a because that's already as a positive exponent, and b also stays the same. However, c would be 1 over c to the power of 21. So all these has exponents of positive. So 3 to the power of 3, 27. A to the power of 9, b to the power of 30, over 2 to the power of 3, which is 8, times c to the power of 21. And all the exponents are positive now. You notice that I didn't have to worry about negative exponents at the beginning or middle of the problem. I took care of that at the end. So at the end, if you have any negative exponents, you make sure to use this property to make him positive. Multiply minus 2 a to the power of 2 times 3 a to the power of 2 minus 2a plus 3. We call a to the power of n times a to the power of m is equal to a to the power of n times m. So we just simply distribute. We get minus negative 2 times 3 would be minus 6. A to the power of, you add the exponents, 2 plus 2 would be equal to 4. And here we have negative 2 times negative 2 would be positive 4. A to the power of 2 plus 1. You notice that the exponent here is 1. So it would be 2 plus 1 would be 3. Minus negative 2 times 3 would be 6. A to the power of 2. We want to make sure that we combine like terms. In this case, we don't have any like terms. So we're done. Multiply (5x plus 2 over 7) (5x minus 2 over 7). Recall, if you have a plus b times a minus b, this would be equal to a squared minus b squared. So in this case, a is the first term, b is the second term. In our case, the first term would be 5x. The second term is 2 over 7. So we do have a plus b times a minus b, where it's called difference of square. When you recognize the equation for difference of a square, you don't multiply these term by term, although we get the same answer. So in this case, we write this as first term square minus the second term squared. The first term is 5x. Second term is 2 over 7. So we have 5x squared, which is 25x to the power of 2, minus 2/7 squared would be 4 over 49. Whereas if we multiply these terms term by term, it would result into the same answer. Again, when you recognize the difference of square property, you should use the property and do not multiply the terms of the binomial term by term. Multiply 3n plus 5m to the power of 2. Recall a plus b squared same as a squared plus 2ab plus b squared, where a is the first term and b is the second term. In this case, our first term is 3n. Our second term is 5m. So we have 3n plus 5m squared is equal to the first term squared plus 2 times first term times the second term plus the second term squared. First term is 3n and the second term is 5m. So we have 3n squared would be 9n squared plus, multiply these three terms together, 2 times 3 is 6, 6 times 5, 30, nm plus 5m squared, which is 25m squared. Multiply 3x minus 4 times 2x plus 1. Multiply 3x by each term in the second polynomial. 3x times 2x would be 6. X to the power of 2, we add the exponents. 3x times 1 would be plus 3x. And then we multiply minus 4 by each term in the second binomial. They give you minus 8x minus 4. Then we have to combine like terms. So we have 3x minus 8x, which would be minus 5x minus 4. multiply 4x to the power of 2 plus 2x minus 1 and 3x plus 2 multiply 4x to the power of 2 by each term with the second binomial. We get 12 x to the power of, we add the exponents, would be 2 plus 1 is 3. Notice the exponents here is 1. Plus 4 times 2 would be 8 x to the power of 2. Then we multiply 2x by each term in the second binomial. 2x times 3x would be plus 6 x to the power of 2. Then we have plus 4x. And finally we multiply negative 1 by each term in the second parentheses. We get minus 3x minus 2. We combine like terms. We have 12x to the power of 3 plus 15x to the power of 2 8x to the power of 2 plus 6x to the power of 2, that would be 14. X to the power of 2 plus 4x minus 3x, I give you 1x, so just x minus 2. So we combine like terms. The first term would be 12x to the power of 3. The second term would be 8x to the power of 2 plus 6x to the power of 2. Then we add them up. 8 plus 6 would be 14x to the power of 2. And plus 4x minus 3x would be simply 1x minus 2. Multiply 2x plus 3 to the power of 2. Recall a plus b to the power of 2 is the same as a to the power of 2 plus 2ab plus b to the power of 2, where a is the first term and b is the second term. So in this case I have a squared plus 2 times ab plus b squared. 2x is my first term. Three is my second term. So everywhere I see a in this, which is the first term, I would substitute that with 2x, and everywhere I see b, I would substitute that with the second term, which is 3. So I have 2x to the power of 2 would be 4x to the power of 2 plus 2 times 2 is 4, and 4 times 3 is 12 x plus 3 squared would be 9. Multiply x plus 2 times y minus 3. Here we multiply x by each term in the second parentheses. We would get x times y, or xy, minus 3x. Then we multiply 2 by the second parentheses. We get plus 2y minus 6. Now we have to see if we can combine like terms, which in this case we don't have any, no like terms. Divide 12x to the power of 3, y to the power of 5, minus 18, x to the power of minus 2, y plus 36, over 24, x to the power of 5, y. Since we're dividing by one-term polynomial or monomial, we can separate these as 12 x to the power of 3, y to the power of 5, 24 x to the power of 5, y, and the second term would be 18 x to the power of minus 2, y, over 24 x to the power of 5, y, plus 36 over 24 x to the power of 5, y, same denominator. So I can reduce this. Again, recall a to the power of n over a to the power of m is the same as a to the power of n minus m. So we have 12 over 24. I can reduce this into 1/2. Then we can divide 3 into 18. That gives me 6. If I divide 3 into 24, I would get 4. That give you 8. Give you 8. Correction. So we look and see if we can reduce anything here. I can see both 18 and 24 first glance are factor of 3. So if I divide that into 3, I would get 6. If I divide 3 into 24, I get 8. But as you see again, they are factor of 2 still. So I can divide both of them into 2. Half of 6 would be 3. Half of 8 would be 4. So this is how we can reduce. Of course, if you can see both of these are factor of higher number, you can divide it into that at first and do that. 36 and 24. You can see both of those are factor of 3. So I can go ahead and divide 24 into 3. I get 8 again. If I divide 3 into 36, I would get 12. And as you see, both of these are factor of 2. So half of 12, that gives me 6. And half of 8, give me 4. And again, they are factor of 2. So half of 6 would be 3. And half of 4 would be 2. So you can keep reducing until you get to the lowest term. If you can find a higher number, of course, you can do that as well. So the first term, we have 1/2. Then we have x to the power of 3 minus 5. And y to the power of 5 minus 1. You can recall that the exponent here is 1. Minus 3/4 x to the power of minus 2 minus 5, and y to the power of 1 minus 1, which reduces to 1 at the end, plus we have 3/2 1 over x to the power of 5 y. So first term would be 1/2 x to the power of minus 2 y to the power of 4 minus 3/4 x to the power of minus 7 y to the power of 0 plus 3/2 1 over x to the power of 5 y. Anything to the power of 0 is equal to 1. And now I have to make all the negative exponents positive by using this property. So we get 1/2 1 over x to the power of 2, y to the power of 4 over 1, minus 3/4 1 over x to the power of 7, y to the power of 0 is equal to 1, plus 3/2 1 over x to the power of 5y. Now all the exponents are positive, so I would get 3 terms here, which would be y to the power of 4 over 2x to the power of 2 minus 3 over 4 x to the power of 7 plus 3 over 2 x to the power of 5 times y. Here we divided and reduced, and all the exponents are positive. Divide x to the power of 4 plus 2x to the power of 3 plus 7x plus 3 over x plus 1. Here when we divide by more than one term, we're dividing by binomial, 2 terms polynomial, so we have to use a long division. Dividing x plus 1 into x to the power of 4 plus 2x to the power of 3 plus 7x plus 3 You have to ask yourself, what times x give you x to the power of 4? That would be x to the power of 3. So you multiply x to the power of 3 by x to the power of 1. That would give you x to the power of 4. Then we have to distribute x to the power of 3 by this binomial. So we have also x to the power of 3 times 1 would be plus x to the power of 3. Here we have to subtract to get the remainder. When you subtract in columns, you can say we are adding, and then we have to change the sign of the second term into its opposite sign. So we have x to the power of 4 minus x to the power of 4. That results into 0. And then here the remainder would be 2 minus 1 would be just 1, x to the power of 3. And we can carry down the rest of the terms and continue. In what times x give you x to the power of 3 would be plus x to the power of 2. And here we get x to the power of 3. We multiply x to the power of 2 by this binomial. X to the power of 2 times x would be x to the power of 3. X to the power of 2 times 1 would be plus x to the power of 2. And here we have to subtract. When we subtract, we change sign to addition and change the sign of each term to its opposite side. So x to the power of 3 and x to the power of 3 add up to 0 when we have one positive and one negative. And here we have to be careful. We don't have x to the power of 2 up here to begin with, so we cannot combine these two. We just have to carry these down to the next step. So we would get minus x to the power of 2 plus 7x plus 3. That would be a remainder. And we move on. What times x give you minus x to the power of 2? Would be minus x. So that would give you minus x to the power of 2. Multiply negative x by this binomial. That will give you minus x times x, will give you minus x squared. Minus x times 1 is minus x. Again, we are supposed to subtract to get the remainder. We're going to change the sign to its opposite sign and add instead. So we have both x to the power of 2 add up to 0. The remainder would be 7x plus 1. X would be 8x plus 3. And we say what times x give you 8x would be plus 8. 8 times x would be 8x. 8 times 1 would be plus 8. To find the remainder, we change subtraction to addition, and we change the sign of the second columns to its opposite sign, and this time the remainder would be equal to minus 5. When we have a remainder, we need a term here. What times x plus 1 give you negative 5? That's what you have to ask yourself. And we can do this in this corner here. What we are asking ourselves here is, what times x plus 1 over 1 give you minus 5? Well, this must be a fraction where the bottom of the fraction must be x plus 1, so I can reduce these two, and the top of the fraction is the remainder, which is minus 5. So as you see here, we have a fraction. You need a fraction. The top of the fraction always would be the remainder, which is minus 5. And here we must put x plus 1. So when I multiply this fraction by x plus 1 cancels each other out, and I would get minus 5 here. So my remainder would be 0. Remember, we're subtracting, we change the subtraction to addition, and all that. So the remainder would be 0. So when you see a fraction here, means you have a remainder, and the remainder here is obviously negative 5. Factor completely. Four x to the power of 2 y to the power of 3 minus 12 x to the power of 5 y plus 60 x to the power of 10 y to the power of 2. The greatest common factor between 4, 12, and 60 is 4. The greatest common factor between x to the power of 2, x to the power of 5, and x to the power of 10 would be x to the power of 2. And among y's, the greatest common factor would be y, the one with the smallest exponents. Here would be exponents of 1, exponents of 2 and 3, so we pick 1. So we factor 4 x to the power of 2y out. What times the greatest common factor give you the first term? Here we are missing y to the power of 2. And then what time the greatest common factor give you the second term? 4 times 3 would be equal to 12. It would be minus 3, so it becomes minus 12. And we have to put x to the power of 3. We add 3 plus 2, we get x to the power of 5. And y is already there. Plus 4 times 15 would give you 60. And then we have x to the power of 8, because 8 plus 2 would be 10, and then we need y here. Y times y would be y squared, and that's how we factor this completely. Factor completely. 5a plus 3y plus ay plus 15. Here we have to use factor by grouping. We need to group this such a way where we factor them, we have something in common between those two. There are 3 different ways we can group this. We can group the first 2 and the last 2 together. In this case, that's something that will help us, because we don't have anything in common between 5a and 3y. Or I can group the 2 middle term and 2 furthest term. And the other possibility would be the grouping the first term and the third term and the second term and the last term. Well, let's see if we can group the first term and the last term together, and then group the 2 middle terms together like that. We have 5 in common between the first 2 terms now. If I factor the 5 out, I would get a plus 3. And I would have y in common between those 2 terms. So we get 3 plus a. As you see, we have between these 2 terms a plus 3 or 3 plus a exactly the same. So I can make both of them to be a plus 3. And then I would factor a plus 3 out. between these two terms. So in other words, what times the greatest common factor, which is a plus 3, give me the first term, here is missing 5, and what times the greatest common factor give you the second term, which is simply y. So we factor this to a plus 3 times 5 plus y. Factor completely, that's 60 x to the power of 2 minus 125 xy plus 60 y to the power of 2. So we have 5 in common between all these three terms, so let's factor that out. I would get 5 times 12 give me 60, so it would be 12 x to the power of 2 minus 5 times 25 xy, and here would be again 12 y squared. Now we factored this, but we haven't factored completely, so we have to open two parentheses here. For 12x to the power of 2, I can use 3x and 4x. That gives me 3 times 4 is 12. X times x times x is x to the power of 2. And then for 12 here, I can use 4 and 3. 4y and 3y. Now, I multiply the two middle terms together. 4 times 4 would be 16xy. If I multiply the two furthest terms together, you mean 3x times 3y would be 9xy. We want to make minus 25xy out of those two. And we can do that if both of these were minus or negative. So we would get minus here and minus here, and notice that 4y times 3y would be resulting to 12y squared. Since both of these are minus, I'll give you plus. So there we have it. 5 times 3x minus 4y times 4x minus 3y. That's how you factor this. Factor completely. 16x to the power of 2 minus 9. Now recall, if you have a squared minus b squared, that would be a minus b times a plus b. Where the first term would be a, the second term would be b. In this case, we have to see if we can make this as difference of square. Here we have 16x to the power of 2. So if I put 4x here, 4 times 4 is 16. X times x is x squared. And here, if I put 3, then I can make this difference of square. In this case, my first term would be 4x and my second term would be simply 3. So when I have 4x to the power of 2 minus 3 to the power of 2, you have difference of square. So it would be first term minus the second term times first term plus the second term, according to this property. Your first term is 4x, and your second term is simply 3. So this would be 4x minus 3 times 4x plus 3. Factor completely. X to the power of 3 minus 8. Here we have difference of cubed that is a minus b times a squared plus ab plus b squared. Where the first term is a and the second term is b. Here you can make this a difference of cubed by putting x being my first term and 2 being my second term. So in this case, my first term is x and my second term is y. In this case is 2. It's 2. So when I have difference of cubed, if I write this formula, my first term is x, so it would be x minus the second term would be 2. So instead of a minus b, I have x minus 2. And then here we have the first term square, which is x squared, plus first term times the second term would be 2x, plus the second term square is 2 squared. So we factor this as x minus 2 times x squared plus 2x plus 4. Factor completely. X to the power of 2 minus x minus 6 Here we have trinomial, nothing in common between those three terms except 1. You open two parentheses. You ask yourself, what times what give you x to the power of 2? In this case would be x and x. Multiply together, you get x to the power of 2. And look at the constant, you get minus 6. What times what give you a minus 6? So the possibilities would be 1 and 6, and 2 and 3. But remember, you want the sum would be negative 1 here. So I would pick 2 and 3. So where I multiply the two middle terms together, I get 2x, and two further terms together, I get 3x. Remember, you want their sum would be minus 1x, so this must be minus, this must be plus, in order to get minus 1. And remember, plus 2 times minus 3 would result into negative 6, and we factor this completely. Factor completely. X to the power of 2 minus 8 x plus 16 you open two parentheses. There's nothing in common between these three terms except 1. So we have x to the power of 2. We can put x and x here. For constant 16, we can use 1 and 16, 4 and 4. Remember, you want the sum be minus 8, so 4 and 4 would give you minus 8 if both of these were minus. So here we have it. X minus 4 times x minus 4. Notice that minus 4 times minus 4 is plus 16. And this is how you factor this. Factor completely. 27x to the power of 3 plus 1. Now this is the sum of cubed. A cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. For the first term is a, and the second term is b. You have to make this difference of, or in this case, sum of the cubed. And we can do that by placing 3x here. When we cube that, we get 27x cubed. And 1 would be the cube, like that would be 1 also. So our first term is 3x. Our second term is 1. So if I place that into that equation, in the formula we get a cubed plus b cubed is equal to a plus b. My first term is 3x plus b, the second term would be 1. And here it says we have to square the first term, which would be 9x to the power of 2 minus ab. 3x times 1 would be just 3x, plus the last term would be 1 squared, which is 1. And we factor this completely. factor completely. 2x to the power of 2 minus 7xy minus 15y squared. Here we don't have anything in common between these three terms except 1, so we open two parentheses. What times what give you 2x to the power of 2? We can try 2x and x. And for minus 15y squared, we get 3 and 5, so 3y and 5y. Now if I multiply the two middle terms together, I get 3xy. And multiply the two furthest terms together, we get 10xy. And remember, you want to have minus 7xy. So this must be minus, this must be plus, this is plus, and this is minus. So when you multiply the last two terms together, you always have to check that. They give you minus 15y squared, and that's how you factor this. Factor completely. You have x to the power of 2 minus 3x plus 2. We open two parentheses. X to the power of 2 give you x and x. 2, we have 1 and 2. If you look at the two closest term and two furthest term, you get 2x and x. Remember, you want to have minus 3x out of this, so these two must be both minus. And we check minus 1 times minus 2 is plus 2, and that's how you factor that completely. The height of a triangle is 2 feet less than twice its base. So let's take a look at the picture. So if this is the base, and this is the height. So they're saying that the height is 2 feet less than twice the base. So twice the base would be 2b. 2 feet less than that would be minus 2. And we know the area is 20. So the formula for area is equal to 1/2 base times height. So the area is given to us as 20, 1/2. The base, we call it b. And the height, we know in terms of b, is 2b minus 2. So here we have an equation in terms of b only, so we can solve for b. We want to solve for the base and height. So let's find the base first. Here I have 1/2. I can multiply both sides of the equation by reciprocal of 1/2, which is 2. So if I multiply both sides of the equation by 2 over 1, then I would get on the left hand side 40, and 1/2 and 2 would reduces to 1. So I would get b times 2b minus 2. That's one way to reduce fractions. Now if I distribute, I would get 40 is equal to 2b to the power of 2 minus 2b. If I subtract 40 from both sides of the equation, I would get 0 here, and then I would get 2b squared minus 2b minus 40. So this is my second order equation where I have to solve for b. I see 2 in common, so I can factor that out. I can factor the 2, so that's just 2 times b squared minus b minus 20 course equal to 0. I move the 0 to the other side. So I can divide both sides by 2 here. So I would get b squared minus b minus 20 equal to 0. Now to solve for b, I can factor this. I have b and 4 and 5. It gives me 20. You want to have minus, it would be minus 5 plus 4. That results into negative b, and plus 4 minus 5 is minus 20. Now I get two solutions here. b plus 4 equal to 0. b is equal to minus 4. This is not acceptable because you cannot have negative for the base. Or b minus 5 is equal to 0, b is equal to 5, and then we can accept this as the solution for base. So the base here is equal to 5. And to find the height, we know the height is 2 times the base, which is 5 now we know, minus 2. So it would be 10 minus 2, which is equal to 8. And the unit here would be 8 feet. Always include the unit. So the base is 5 feet and the height is 8 feet. The length of a rectangle is 2 inches more than 3 times its width. Let's take a look at the picture. So this is the width. The length is 2 inches more than 3 times the width. So it would be 3 times the width plus 2. So we have the width would be equal to W. The length would be 3W plus 2. But it says the length is 2 inches more than 3 times the width. 2 more than 3 times the width. Now the area is given to us as 33. So the area is equal to length times width. Area is 33. The length is given to me as 3W plus 2, and the width is W, so we solve for W here. Go ahead and distribute. I get 33 is equal to 3W squared plus 2W. I can subtract 33 from both sides of the equation. Okay, we factor this, we would get 3W and W for the first term, and then we have 11 and 3 for minus 33, and then in order to get plus 2 we have plus 11 and minus 3 here. So we get two solutions, 3W plus 11 equal to 0, 3W is equal to minus 11, W is equal to minus 11 over 3, which is not acceptable. We need a positive number for the width, and we get width is equal to 3, so the length would be equal to 3 times 3, which is W in this case, plus 2. 9 plus 2 is equal to 11. So we have the dimension here would be inches, 3 by 11 inches. One leg of a right triangle. Let's take a look at one. We have a right triangle here. One leg of a right triangle is 1 meter longer than the smaller leg, and the hypotenuse is 2 meters longer than the smaller leg. So let's assume we have A here being the smallest one, and this is B, and this is C. So if I let A be the smaller leg, then B is 1 meter longer than that, so it would be A plus 1, and the hypotenuse C is 2 meters longer than this, 2 meter longer than the smaller one. So it would be a plus 2. So the Pythagorean theorem says that we have c squared is equal to a squared plus b squared. In this case, our c is a plus 2, and our a is a, and our b is a plus 1 squared. We call a plus b squared is equal to a squared plus 2ab plus b squared. So we have a squared plus 2ab would be 4a plus 4, and in this case we're missing square here, so we have a squared. And here we have a squared plus 2ab plus b squared. So if I move all the terms to one side of the equation, I would get minus a squared minus 2a minus 1 equal to 0. We move each term to the left, its sign changes opposite sign, and here we reduce a squared here, 1 plus 1 minus. Then we have minus a squared here. We have 4a here, minus 2a, that give you plus 2a, and we add the constants, we get plus 3. If I multiply each term by minus, I would get equation where I can solve for a, and I factor this, I would get a and a here, 1 and 3, and then here we want to have minus and plus, so we get minus 2, the whole thing is equal to 0, of course. So we have a plus 1 equal to 0, a is equal to minus 1, that's not acceptable, we cannot have a minus for the length. And we have a minus 3 is equal to 0, so a would be equal to 3. So we find the base is 3 meter. So the other leg would be b, which is a plus 1, which is 3 plus 1, which is 4 meter. And the hypotenuse would be equal to a plus 2, which is 3 plus 2, which is equal to 5 meter. Simplify. 5x to the power of 2 minus 2x plus 7 minus 3x to the power of 2 minus 4x minus 3. We distribute minus, or you can call this minus 1. So we have 5x to the power of 2 minus 2x plus 7 minus 3x to the power of 2 plus 4x plus 3. We combine like terms. we would get 2x to the power of 2 plus 2x, and then we add the constant plus 10. Solve by factoring. Six x to the power of 2 minus 7x minus 5 is equal to 0. Here we have 6x to the power of 2, we have 2x and 3x, that gives me 6x to the power of 2, and for minus 5, we have 1 and 5, and here we have 3x and 10x. You want to have minus 7, so this must be plus, and minus 10, we need minus 5 here to get minus 10. So we have 2x plus 1 equal to 0. 2x is equal to minus 1. X equal to minus 1/2. Or 3x minus 5 is equal to 0. 3x equal to 5. X is equal to 5/3. Solve by factoring. X to the power of 2 is equal to 5x. I can subtract 5x from both sides of the equation and factor x. So either x is equal to 0 or x minus 5 is equal to 0, so x is equal to 5. Solve by factoring. 10y squared plus 15y minus 45. We have 5 in common between these three terms, so we factor the 5. First term would be 2y squared. The second term would be 3y. 3 times 5 is 15. Minus 9. 9 times 5 is 45. So if I divide both sides by 5, I would get 2y squared plus 3y minus 9 is equal to 0. So here I can factor this again. So we get 2y and y, and for 9 I get 3 and 3. To get plus 3, we have 3y here. Here we have 6y. So you want to have plus 3, so this must be minus and this must be plus. Notice negative 3 times plus 3 is minus 9. So we have 2y minus 3 is equal to 0. 2y is equal to 3, y is equal to 3/2, or y plus 3 is equal to 0, y is equal to minus 3. Solve by factoring. X squared is equal to 36. We subtract 36 from both sides of the equation. This is the difference of square. So the first term would be x, the second term would be 6. 6 times 6 is 36. Minus and plus. Recall a squared minus b squared is equal to a minus b times a plus b. So x minus 6 is equal to 0, x is equal to 6 by adding 6 to both sides of the equation, or x plus 6 is equal to 0, x equal to minus 6 by subtracting 6 from both sides of the equation. Solve by factoring. We have z times z minus 7 is equal to negative 10. Here we distribute, we get z squared minus 7z is equal to minus 10. We add 10 to both sides of the equation. And we factor for z. Factor is trinomial. Z and z, 2 and 5, it's 10. Both has to be minus to make minus 7 out of this. Negative 2 times negative 5 is plus 10. So z minus 2 is equal to 0. Z is equal to 2. Adding 2 to both sides of the equation. Or z minus 5 is equal to 0. Z is equal to 5 by adding 5 to both sides of the equation. Solve by factoring. Here we can factor 5x. The first term becomes x to the power of 2 minus 3 times 5 would be 15. So it's 3x plus 2. And then we can factor completely. Here we have x, 1 and 2, both has to be minus to make negative 3x. Negative 1 times negative 2 is plus 2. So we have 5x is equal to 0. So I divide both sides by 5. X would be equal to 0, one solution. Or x minus 1 is equal to 0. You add 1 to both sides of the equation, so we get x equal to 1. Or x minus 2 is equal to 0, so x equal to 3 by adding 2 to both sides of the equation. Oh, this is 2. adding 2 to both sides of the equation, so x would be equal to 2. So the solutions would be 0, 1, and 2.